Hello everyone. In this video we are going to see the Internet of Things concept. So whenever you talk about Internet of Things, there is one world what we call is a physical world and another one is a digital world. So we know that today everything is connected to internet. So one of the best example for Internet of Things is our smart homes. In smart homes we are having our smart appliances. Smart appliances like refrigerators, air conditioning systems like uh, and what we can see are smart lighting systems. For example, you just left for an office and you forget to switch off your light. So from your office, by just single click on your phone, you can switch off that light that you forgot to switch off at your home. So that is what it is, that things which are connected to internet that can be controlled, monitored remotely from anywhere. Here when we know about the digital transformation, we are having a social mobile cloud and information and our digital which is connected with the physical things and the business part. So how my IoT part was evolved. Basically when I talk about IoT, it is a system of interconnected computing as well as non-commuting communicable devices and objects for information exchange without human intervention. Because here when I want to check whether my system is whether my light is on or off without any human intervention, like there is no human involved at this place at home, from that I can check whether my light is switched on or off. That is what defines IoT, Internet of Things. So basically it is how it was, how it should be and how it will be, we will see. So when we talk about where we are today is we have reached up to connect device, like we have reached up to connectivity and intelligence, connectivity plus intelligence. What we are doing, we are collecting the data, just like we are measuring the temperature, we are measuring the humidity, we are measuring the whether light is on or off and so on. The next stage is our security challenge. We are accessing the data, we are sending that to the cloud. We know that there are various types of clouds like Amazon AWS and Microsoft is there, and then there is a ThinkSpeak cloud servers, and there are lots and lots of servers. Also we are having an open APIs from which we can collect the data. After that there is a complex analysis. Now we are having the data. What we need to do? We need to do analysis on that. So there will be complex analysis. What we need for that? Big data, because of large data collection. Then comes our unique value, realizing the true potential of the connected society. That is ideal goal for many years away. Like we are getting the information, but we need to find that unique value from that collected information, right? Now when you talk about IoT key drivers, okay, just I will remove this. Yeah, IoT key drivers. When I talk about IoT key drivers of IoT is customer expectation. Second is smart grid technology, smart homes, clean energy availability, economic viability, automation, quick response requirement, seamless data exchange, and less human intervention. The less human intervention is one of the main thing. So basically when I talk about the Internet of Things, okay, if I divide this, so it can be anything, any device. Okay, anything, any device. Here comes anyone, anybody. Here comes any service, any business. Here comes any path, any network, any place, anywhere. Here comes anytime, any context. That is what defines our IoT. Now when we see our wireless sensor network in the previous case and IoT in this case, so what are difference now? So let's see with the context of human body. We know that human body has ears, eyes, brain. So wireless sensor network, the sensors are ears and eyes of IoT because they can see everything, they can sense everything. But to process that information, we require IoT. So that is a brain on the top of the wireless sensor network. Now, when we talk about wireless sensor network, it that connects the real world to the digital world. Just like we want to move from one path to other, we need some bridge. That's why in the real world to the digital world, we need some bridge, that is our wireless sensor network. IoT is process and stores the real world data. Then comes for short distance transmission, we use our wireless sensor network, and to make meaningful interpretation, we use IoT. Limited processing capabilities it has, whereas it makes decisions based on the sensed data which is sensed from the wireless sensor network. Here energy is a main constant, that's why, and here it's generally power device. So when we talk about the requirements, security and privacy is medium in case of wireless power transmission, wireless power network, and in IoT it's high. Robustness is high in both, scalability is high in IoT, quality of service is high, heterogeneity is high, and there are lots and lots of things like data processing is also high, identification of things are also high, power and energy management is high in wireless sensor network. Then comes what is my role of IoT in power system. Okay, so let's delete this part and this part also. Yeah, when we talk about the role of IoT in power system, the IoT provides better ecosystem to address free of the monitoring and control challenges. Basically with IoT I can just remove the monitoring and control challenges, monitoring plus control challenges which I am having in our power system network. So what IoT does is it changes the system as is to 2B system, like what we are having today to what we are going to have tomorrow. IoT change that to system. Like today we are having the traditional measurement system, but in coming time we will have an advanced real-time measurement, like what we already got, advanced real-time measurement. As if is manual control, to be is automatic control, what we already got, non-interactive and interactive to be, like we are having a graphs and visualizations of everything on cloud, static visualization, and here we are having dynamic visualization. Customer, here it is as is a customer, and here is a consumer. He can sell electricity to electricity market, he can participate in the energy trading, he can be a active customer means a consumer. Conventional event analysis is there, and today we are having a smart analysis. If I talk about IoT architecture, like IoT architecture has one of the main advantage. Starting with the IoT edge things like sensors, actuators, devices and applications that are connected to field connectors through Bluetooth, Wi-Fi, NFC, Zigbee. And further it is connected to the smart gateway capabilities of routing, data flow, monitoring, storage analysis and management. These all things are connected to the cloud-based system. To send the data to the cloud, we need some protocols, that is our MQTT, AMQP, HTTP and COAP. And then the cloud or own server we can send data, that is our IoT platform service. This is my IoT platform service. If I talk about this part up to this, it's IoT smart gateway platform, right? So basically we'll see about different IoT architectures. In that, one thing is our MQTT. To transport that part, like message queuing telemetry transport, it's basically a publish subscribe based messaging protocol. It works on top of TCP IP protocol. Message queuing telemetry transport, it is designed for limited bandwidth connections. Then comes AMQP, advanced metering queuing protocol, an open standard for passing the business logic between the applications or organizations. Then comes COAP, constant application protocol, specified web protocol to use with the constant nodes and network. This protocol is designed for machine to machine apps. Then comes our XMPP, that's open XML technology for real-time communication. Extensible message and presence protocol, full form of this.